So yeah, I'm Dom Guinard. I'm the CTO and co-founder of a company called EVRYTHNG, without the vowels. And you'll see later on why we're called EVRYTHNG, but we're basically an IoT platform. And I thought I was going to tell you a bit more about IoT and taking more of a DevOps hat, of course. So I'll be talking a little bit about the IoT toolbox and especially talking about a few challenges that you encounter in building an IoT platform or generally an IoT product. And I'll be talking about heterogeneity, which is a word I can't say, so unfortunately you will have to bear with my French accent. I'll talk about scale, much easier to say, physical wall deployments, and also the fragmentation of application protocols and what are the tools that we can use to fight against that. But first of all, I have to start with what is the IoT. And I have my very own definition of the IoT. But basically, you know, the IoT is everywhere. You hear a lot about it. When I began with the IoT 10 years ago, it used to be a swear word. IoT meant RFID, and RFID was not seen as a good thing. But then the world moved on, and today you have crazy projections all over the place, talking about 50 billion things that will be connected by 2020. I think, by the way, this is largely underrated, so I expect it to be more like 300 billion. And every single company is somehow getting into that business. But my own definition of the IoT is the following. The IoT is a science primarily focusing on creating the most complex ways of turning lights on. I've been in that business for 10 years, as I said, and I spent a lot of time actually building this prototype for different customers and different people. So pre-IoT, you had a lamp, you had a light switch, job done, right? That's how you were turning on the light. Post-IoT, things are a little bit more complex. So you use a blend of 10 apps, 10 different protocols, and you have 10 buttons, and you don't know which one to use, actually. But joke aside, that's a pretty big problem. So the IoT was meant to be resolving many, many problems. And of course, I'm pushing it to the extreme here. But if what we're building is an IoT of 10 devices, 10 apps, then we're not really reaching anything, right? Home automation has been around for years. And home automation started in the 70s, 1975, working with protocols like BACnet or X10. If we really want to bring it to the next wave, we have to think about the internet. We have to think about the convergence, and I'll be talking a little bit about that. But the reality is this heterogeneity will still exist, right? And there are a few reasons for that, right? I mean, you need IoT protocols, and you need different IoT protocols because they have different strengths and weaknesses. And there are good reasons. There are also very bad reasons for making your IoT life complicated and not going with a simple mainstream protocol. I mean, the reasons I've seen in my career and with our customers are usually three main reasons, right? One is cost, one is battery consumption, and the last one is the infrastructure that's available. If actually these are not necessarily a problem for you, so if your device can be a bit more costly, if it's not battery powered, and if you kind of have a pretty easy to deploy infrastructure at hand, then take the shortest path, right? Do not go into crazy, complicated IoT protocols. But there are reasons why actually you might want to think of different protocols. And one reason is that we have different operating systems. And one big factor here is cost, right? So on the right-hand side here, we have the devices which are 8-bit microcontrollers with a order of 10 to 100K of RAM, and same thing with the ROM, right? These devices are actually dirt cheap. You can really buy them at scale for something around $1 with full IoT stack, full connectivity, right? Some of them are much more powerful, much more beefy. So that's the Intel Edison and Raspberry Pi Zero. These are multi-core. They have in the order of several gigabytes of RAM and several gigabytes of flash. So cost is really one factor that actually could make you choose a device that's much harder to integrate with, leading to more heterogeneity. This is, however, changing, right? Things like the Raspberry Pi Zero, just on a cost point of view, has a cost of £4. So, you know, we're getting there. Another factor is when you need different topology, and in particular when you need something like a mesh. A mesh being, you know, you have one device here, you have another device there. You can actually use several of the devices in between to talk to your device. Typical use case for that is when you want to drop sensor nodes in a jungle, for instance, right? You don't really have a nice infrastructure at hand to communicate, so you can rely on this mesh networking, and that's going to help you. And then there are a number of good IoT protocols that help you deploying meshes. An example is Zigbee. Another example that's coming soon is Bluetooth Mesh. Bluetooth Mesh should be a standard pretty soon, touch wood. They've been announcing for a long while, but it should be sometimes in 2017. So this is an example where you would choose something like Zigbee or Bluetooth over, say, something like pure web internet stack, TCP/IP and etc. IP, TCP/IP based on Wi-Fi or Ethernet. You also have a number of protocols that actually are very interesting from a battery consumption point of view this time, right? So going the full Wi-Fi way is very easy to deploy a product. However, it consumes a lot of battery, right? So if you have a device that's completely battery operated, there is a huge difference between running it fully Wi-Fi or running it on a protocol like Zigbee. There's even more difference in running it on a protocol like Zigbee and a protocol like LoRa or Sigfox. Who here knows about these two protocols? Yeah, they're not very widespread, but actually, yeah, a few people. What's happening in the world of IoT is that mobile operators for IoT, if you want, are mushrooming. Basically, they're creating, just like the mobile operators, they're creating a network that they're deploying. That network is very low power in the case of Sigfox and LoRa, and is really tailored for IoT devices. So you have a very low power network, very low cost network that you can use for your devices. And it's brilliant, actually. Everything integrates with Sigfox. Sigfox is really a device. You drop the device anywhere in London, it will connect directly to a mobile base station, and off you go. You can start sending messages. So there's really a lot of value, especially if your device, again, is battery powered. Of course, there are drawbacks and there are flip sides. One of them being that the bandwidth of a network like Sigfox or LoRa is very small compared to what you have on Wi-Fi or even Zigbee. Interesting in this space, the Things network is trying to go completely open source, so creating a completely open source, crowdsourced, low power, wide area network. That's how you call these different LoRa, Sigfox, etc. So the Things network is trying to do that completely open. And then you have great innovations that look at this battery consumption problem. So one that I like is FreeVolt, based here in the UK. And what they do is they do energy harvesting devices. So this is a full Bluetooth device that I actually carry in my backpack all the time. It measures the air pollution. So let me tell you, lately it's always in the red. But I actually dropped it in my backpack and never touched it again. It harvests energy from all the electromagnetic fields that are around us. So I'm pretty sure right now it's at max power, thanks to you all. So there is also here really a meaning in using these different ones. Okay, you also have different app protocols, and again here the same thing, these application protocols, right? I'm a big advocate of the web, as you'll see later on. So I would say if you can, use a web protocol on your embedded device. But if you can't, again, for the same reason, usually power consumption and cost, then there are some nice alternatives. MQTT is one that was developed years and years ago by IBM. It's a great protocol for IoT, and it bridges very easily to web and internet. And then there are web-inspired protocols like CoAP, which is taking the whole of a RESTful architecture, but actually re-implementing it. So it's not HTTP, it's REST, it's not HTTP. It's implemented in a much more lighter way. HTTP2 actually borrows a number of things from CoAP, such as the binary transmission and so on. So HTTP2, for instance, is a protocol that will be much more suitable for IoT devices. So the reality is you will have several of these different protocols that you have to deal with when you deploy an IoT project. But there is an answer, and that answer is the web. We think that the web has the potential to make the IoT accessible, to give an API to every single thing on the web. So the Web of Things, I would call it, is about bringing order in the IoT chaos by using web good practices, right? Some people might say that the Web of Things is about using web protocols to find the most complicated way to turn lights on and off. But I think it's actually about simplifying that. So, in a nutshell, sales pitch is that here you have the Internet of Things with all the protocols, right, that we unfortunately have to live with. Some don't make sense, right? Like, for instance, the fact that we have Zigbee and Thread doesn't make sense. These are so much overlapping that they should merge into one, right? But sometimes you have to have different ones. And actually, what we're advocating is, well, okay, but at the application level, bring them to the web. As much as you can, always converge to the web, because this means that you can eventually get out of this world of 10 protocols, 10 apps, right? You can converge everything at the web level. And that's what's called the Web of Things. You know, if you never heard this terminology, this was my PhD and also the PhD of other people. And what I did during my research at MIT and ETH Zurich was basically bringing these devices to the web and showing how at different layers the web can help. So at the access layer, you can actually deploy web protocols on devices. That's fairly feasible. HTTP and WebSockets are great at covering many, many use cases. Then you can use the semantic web to do things like discoverability, findability, things like JSON LD that you just add to your JSON payload, starts to put semantics so that machines can understand each other, but still the web way. And then you have sharing and security. So security, you can of course leverage the goodness of web protocols and sometimes adapt it. So that would be DTLS versus TLS, for instance, where DTLS is a lightweight version of TLS for embedded devices. But it's also showing that you can leverage things like social networks and so on to basically share data from different things. And then you can actually see that once you bring all these things to the web, composing them becomes very, very simple. So you have great mashup tools that actually let you compose Internet of Things devices. A good one is called Node-RED, if you want to give it a try. Another one that lets you basically pipe data from different devices that are web-enabled is called IFT. So the basic principle is actually giving a URL and a web API for each thing, right? And that's what we did pretty early on with this device that you can find online, where people can send messages and people can interact with all the hardware of the device using purely web protocol. When we launched that, it seemed like something completely new. Today, it might seem to you quite obvious to use web protocols on devices because the world has moved on, and a lot of devices have actually adopted this Web of Things philosophy. That's a device, for instance, that has adopted the Web of Things philosophy, although it existed way before. So the Large Hadron Collider at CERN is actually controlled via HTTP, just to give you an example of a pretty big, beefy device that uses HTTP. I think this one has enough compute power, though, but... And yeah, the web has moved on, right? And you see this convergence towards internet, towards web happening all over the place. So you have lots of devices that actually now speak web natively. They use HTTP, they use WebSockets natively on the device, and that makes things much simpler. Some of them are fascinating one, like the Arctic one from Samsung is actually implementing Node.js on a 16-bit, very, very low power microcontroller. So this is, these are great projects showing the future. Okay, another big pain point and another thing that's challenging in the IoT and in deploying an IoT solution, where there is also a nice solution coming from the DevOps world and generally the web, are deployments. So deploying code on physical things is much harder than deploying code on, say, servers in a cloud, right? I mean, there are lots of complexities, right? But actually, it's very important you can, right? It's very important you can push new code, you can push patches on a regular basis to IoT devices for obvious reasons, right? I mean, security is a big one. We're talking about TLS certificates expiring. Well, that also happens in the real world, right? So you need a way to actually push your new certificates to the devices. And there, I've come across two very interesting solutions that I just wanted to present to you, and I have no affiliation with these solutions, but we use them and we like them. So one of them is called Resin.io. So what Resin did is actually they took the concept of Docker containers and implemented it for embedded devices. So they had to re-implement bits and pieces of Docker, and so that's the picture on the left, right? And basically what they did is these modifications based on a base Linux called Yocto. Yocto is a great Linux for embedded devices. And then what they do is they deploy their own container alongside you deploy your application container, right? So you have these different containers on embedded devices. And these embedded devices can be very, very resource constrained. So that's very easy to deploy, for instance, on a Raspberry Pi or even lower power and lower computation devices. What they provide you is the entire infrastructure, the entire cloud service to basically Git push to 100,000 devices. And that's actually beautiful, right? So you can now push your code via containers to a lot of different devices out there. And the way they do this is they basically maintain a VPN connection to the devices, and they push the diffs of the containers to the devices on a regular basis. That's very good for several reasons. It lets you do very frequent updates. It's also very hard to lock a device. If you implement your own solution, it's very easy to lock a device. I've experienced that the hard way several times. With that, you can really ensure that a deployment never locks the device. There is a similar offering from Ubuntu that I've grown more and more interested in. It's called Ubuntu Core. And what Ubuntu Core is trying to do is they're trying to implement they did implement a much more lighter version of Ubuntu that's also that also offers containers. They're not Docker containers. They re-implemented their own. But basically you have this very lightweight version of Ubuntu, and then you have these different containers. The difference with Resin and Ubuntu is that Resin is much more focusing on a very simple workflow to deploy to a very large number of devices. Ubuntu is very much focusing on having a lot of applications on a single device in containers. So you also have the notion of app store, so you can deploy, even on an embedded device, an app store, and this app store can load several different bits of code. You might be wondering, why would you do that? So imagine a lift. You can actually push new services to the lift, right? Like a VIP service. Whenever I swipe my NFC badge, there is a VIP service that was downloaded by the lift that actually lets me access to my floor faster, right? So these things that you didn't imagine in the first place with a solution like this, you can start deploying them to the physical world, and that I find fascinating. Another thing that's very challenging with IoT is scale, obviously. And there, what we do is a lot of scale testing and preventive testing. When you start tackling IoT challenges, it's interesting to look at the numbers, right? So I have this graph when I try to explain to our customers that scaling IoT is hard. Basically, imagine Twitter, right? And imagine the number of messages per day on Twitter. Now think about the 60 or 50 billion devices we're talking about, billion, right? But let's take, I don't know, let's take 100,000 IoT devices sending an update every 2 seconds, right? That's what? That's 25 times Twitter, right? In terms of load. So very, very quickly, you have very, very high loads in IoT because machines are very chatty and they never stop talking. Some humans are like these. And on top of that, they have very, very, IoT use cases have very, very hard requirements to achieve. Like, you want them to be predictable, to be low latency. It's very fast growth, very fast increments. And quite often, there's a lot of need for computation in the cloud. When a message reaches the cloud, it's not only stored in the cloud. Usually there is a rule that's triggered, right? And there are lots of tools that can help, right? So things like Lambda and serverless architectures for us were really great and really life-saving. But in terms of predictable low latency and fast growth, fast increments, that's actually challenging. And our approach is simply preventive testing, right? And there are two tools that we really like in doing preventive testing. So whenever a customer onboards with us, we actually go into using these tools. And one of them is Gatling, and the other one is Flood. So Gatling basically lets you create very, very specific scale test scenarios. And it's very, very good in terms of scaling. It really uses the most of a machine in terms of creating simulated clients on a single machine, much better than JMeter, for instance. And Flood.io is a great service that we use to actually run Gatling tests in the cloud. So Flood.io is, of course, built on Amazon as well and lets you deploy a lot of clients by the click of a button to simulate very, very large scale. Talking a little bit about how we apply that at everything. So we actually work with a number of big customers. You can find them here. And basically, we become their IoT platform whenever they want to digitize and connect their products. Let me not go through the architecture because I'm short on time. But basically, an example would be we power all the devices of iHome. iHome is a big American brand, and we're the cloud behind that. iHome is an interesting one because it's based on very cheap embedded devices, so we had to make some compromises. It's also interesting because that particular device, for instance, is plugged permanently, so it doesn't have the battery problem. So in that case, we picked with them Wi-Fi and MQTT, and that's actually great. And then we convert MQTT into WebSockets so that applications can talk only web to the backend and to the devices. They do not need to know any other protocols. GUI is another example. That's lighting as a service. So that's about turning LEDs on and off. But it's actually very, very smart. It's filled with sensors. So there, the thing is, because the lights had to remain very cheap, they don't have direct Wi-Fi connectivity on the lights. That would also be a problem when you deploy 50,000 lights in a building. So they use Bluetooth, and then we have a gateway, and this gateway converts Bluetooth into web, both locally and remotely. I'll skip these ones to basically just mention that everything is today 60 people worldwide. Also, thanks to the guys at Linux Recruit, we got quite a few people from there, and we're very happy with them. Some of them are in the room. And we managed to close to 1 billion unique things and billions of not unique things. And we're always hiring I also wrote a book about all these concepts. If you're interested, it's called Building the Web of Things. And the first one that tweets something good about this talk, I will give them a copy. So just try it. That's a free book that we wrote also, if you don't win the single free book, that talks about these different concepts.